Hey everybody, this is Larry. This is day 3 of the Leetcode Daily Challenge for October. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And today's problem is K-diff pairs in an array. So I'm solving this live. Let me know if it goes wrong or whatever. And let me know how you solve this. Okay, so given an array of integers nums and k, return the number of unique k's of nums. Okay, so basically... okay, as long as I is not, you go to J. What is A is, okay. So that's a pair, but they don't tell you what a unique pair is. Because unique pair could mean just unique index or something like that, I don't know. But 1 and 3, okay, 1 and 1, oh, that's weird. 3, I guess that is, okay. Okay, so I think the technique that I'm thinking of is similar to prefix sum dynamic programming or something like that, but it's just a lookup table, right? Basically, for example, for 3, you may look for 1 and 5 for k02, and then you just kind of keep on looking backwards. So the tricky thing about that is that you have to keep track of uniqueness, right? And there are a couple of ways to dedupe. The way that I'm thinking of right now, or I was just thinking of, is just keep track of the larger number. And I think if you do that, then you should be okay. Space complexity may be a little bit iffy. It adds another linear thing, but it should be the same either way, right? Because it's going to be linear if you use a hash table. And I think you could also do it another way where you sort and then do a 2 pointers algorithm. That's n log n, but with one space. So you could choose either of those two things to do. And I'm going to do it the lookup table way with the linear time, linear space way. If you have time, do practice the n log n constant space one, because I think that comes up in other problems, or maybe even in this problem if the list is sorted or something like that. But yeah, that's what I'm going to do. Basically, so basically, I have I'll have two sets. One is set of numbers that we've seen, and then higher unique pair, higher number, something like that set. And we'll go over what those two things. And seen is just basically the set that I will use to represent all the numbers that I've seen from the left of a given index. And then higher unique number is just a number we're going to return that are going to be that would give us the answer, and it's just basically there to help us dedupe. So let's get started on that. So let's for number in nums. Okay, so if so current let's put a number. Current number is I guess number is already current number. Oops. So if I think so what I'm struggling a little bit and just thinking through is either I need num minus k or k minus num. I think in this case we want either or both, because looking back you could go the other direction, right? So okay, so if this is in scene or not in scene, then we or not in oh yeah, wait. If this is in scene, that means that the smaller number, nums minus k, is seen, right? So that means that we want to put the higher number of in higher unique number. And in this case, this is going to be in theory nums if it's positive, but because we have negative numbers. Now, even if negative numbers, it would just be smaller, right? So that means that in this case, we want to add higher unique number that add just num, right? And then if num plus k is in scene, then we just do higher unique number that add num plus k. And then after that, so the reason why is because what we want is actually max of nums and num minus k. But because num is always going to be bigger than num minus k, and as k is negative, and k is positive, right? So then, we can reduce this to just nums. Similar thing with nums plus k, right? Because we're just comparing nums or num and num plus k. Okay, and then now after that we process it, we could add it to scene. Okay, and then now at the end we just return the length of the higher unique number, and I think that should be good. Let's run this, and also let's put in these test cases. I say because this is annoying to do copy and paste. Pretend there's a montage. Pretend I'm playing music. Probably songs that would get me in trouble with copyright, but you know, let's pretend I'm doing that and maybe skip forward like 15 seconds while I do some copy and paste. I always say that you should do a copy and paste, but I guess in this case that's a little bit not what they mean. Okay, so let's run the code real quick. So the bare minimum that I always do on testing is always at least test the inputs that they give you, because at least you know the answers. I think the other one is maybe something like that. I think this one's already given some variation of it, but let's say 1, 5, something like that. And then just, can n be num? Nope. Okay, so I guess just one. I mean, it doesn't really matter or shouldn't matter. Cool, so it looks okay. Let's submit it. Sweet. Yeah, so this is by itself, this is a straightforward problem, kind of. It's not that easy, but it's not that hard. It's something that if, you see again and again in Leetcode, so definitely practice with it. That's why I say that you should get used to it. But this idea of the scene array is something that is the basis for what I call the prefix sum. Sometimes prefix sum, but just the prefix dynamic programming, where you have to look up something from a prefix, either the sum or some function over the prefix, right? And that comes up a lot in dynamic programming, at least on Leetcode, because I think it's in the meta or something, I don't know. But I've seen it more than I feel like I did, say, 10 years ago. But it is what it is. So definitely practice, familiarize yourself with it. And also, if you have time, like I said, you could sort the nums and then do the 2 pointers. Of course, I just gave you the algorithm, so it's not that hard. But sometimes you get off by one with implementation, so definitely play around with that. And let me know how you did. Let me know what you think. Again, just to go over it, because I don't think I did explicitly, I said it in the beginning. This is linear time and linear space. Linear space is these two, and linear time is that it takes O of 1 for each of these, assuming hash table is O of 1, depending on who you want to ask. But yeah, that's all I have for today. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and I will see y'all tomorrow. Bye-bye.